So we are now discussing about types of stress basing upon the force applied. So first one is tensile stress, and this force has equal and the opposite forces. Opposite forces means two forces, pair of forces acting in the different directions. They are directed away from each other. These two forces do not act in the same direction. One force in upward direction, one force in downward direction. Later, another stress is the compressive stress. So, this compressive stress occurs when equal and the opposite forces are directed towards each other. So, the difference between tensile stress and compressive stress is tensile stress are forces acting in the opposite direction. They are away from each other, and here the forces are acting towards each other. That is the difference between compressive stress and the tensile stress. So in our present lesson, the force acting on certain dimension is called stress, and we study about three types of stress. First one is tensile, another name longitudinal stress. Second one is volume stress, and the third one is the shearing stress. So in the longitudinal stress, these three forces are applied force, that is the force which is applied externally. Suppose if the applied force changes the length of a body, then that is longitudinal stress. Change in the volume of the body, volumetric stress. Change in the shape of a body, then that is called as shearing stress. So the change occurs in length, volume and shape. If it is length, then the name is longitudinal. If it is volume, then volumetric stress. If it is change in the shape, then that is called as shearing stress. Now, the relation for the stress is force by area. This is the general formula, force by area. But here is dimension of a body according to the length of a body. Then the longitudinal stress is force by area. Force acting on the body is mc, area pi r square. Similarly, when we correlate to the volume stress, the formula is force by area, and the force is A into dP, that is the change in the pressure of the body, by area. Both AA cancel, then we get dP, change in the pressure of the body. Later, the change in the shape of a body, that is shearing stress. Formula is tangential force acting on certain area of the body. Later, due to application of this stress, we get changes in the dimensions. The changes are called as the strain, and we have three types of the strain correlating the three types of the stress. So longitudinal stress, previously we discussed, correlate with the longitudinal strain. Volumetric stress correlate with the volumetric strain, and shearing stress, which is correlates with the shearing strain. So first one is change in the length. So here we referred changing the length by original length, changing the volume by original volume, changing the dimension by original shape, that is the length of a body. Actual formula for the stress is force by area. Due to this is input of the body, and due to this input we are getting the output. So we get longitudinal strain as output for longitudinal stress, and volumetric strain for input of volumetric stress, and shearing strain for the input of the shearing stress. So this is about three types of the strain inside our lesson. Later, after learning stress and the strain, so there exists certain limit for a body. Even though we apply large amount of the force, body will be breakable even though it is elastic body. So the elastic nature has certain limits, that is called elastic limit. So within the elastic limit, the applied stress is directly related to the strain. So stress is proportional to the strain. If we replace proportionality, then we get m. It is a constant because we are referring the constant in elasticity. So it is called modulus of elasticity. This is the formula. If you take m, then strain will goes to LHS by, already stress is there, so stress by strain. This is the formula for the